Hi everyone, I'm Natasha and I'm from Team 34, and together with me are my friends from Computing Science and Mechanical Engineering from both the Mechatronics and Design track. So this will be the agenda for today. And moving on, we'll be going through the problem identification first. So in the current context, nurses actually uses syringes on a daily basis actually for feeding. However, I think it's actually quite known to us that after every feeding, they tend to dispose of it. So if you want to know why, it's actually because of these 6 reasons on the slides here. So however, on a long run, it is actually not good to do so because it affects the environment. It impacts the environment negatively, and also because it requires a lot of unnecessary costs to purchase the new syringes and for wastage disposal. So moving on, the first market research is to go through the product. So the first product that we will highlight is the Tommy TP Advanced Stirring Dryer Electric Sterilizer. So this product is actually for bottles, and it actually sterilizes and dries up to 6 bottles in 40 minutes. And it's sterilized for 24 hours with their lid closed. So the second product is actually Dr. Brown's Bottle Sterilizer and Dryer. So for this one, they have 3 specific functions, such as sterilize only, dry only, or sterilize and dry. So similar to the first product, it actually allows the content to stay sterilized for up to 24 hours with unopened lid. So the next part will be the need finding analysis. So for the need finding analysis, there are 9 different requirements that we decided to follow. So first is to have a fast turnover time, rapid drying, have a sterilization function, automated washing, drying, and sterilization, easy to use, reduced contamination, low maintenance, size not too bulky, and of course low cost. So the next part will be the system process flow. So it is actually split into 3 different phases, which is washing, rinsing, and drying. So for the washing, there'll be a variable called ml count, which I will explain later. So this ml count will actually be set to 0. So afterwards, the syringe and plungers are separately placed at the rack by the nurses, and the start button will then be pressed. So upon that, the water will be pumped in, and it will clean the ultrasonic. It will be cleaned by the ultrasonic washer for about 10 minutes. So afterwards, the rinsing phase comes in, which allows the timer to be start, and then the water will be drained using the liquid pump. Stepper motor rotates at 5 to 10 revolutions per minute, and the water jet starts. So these 3 functions actually repeats concurrently for 5 minutes. Yeah. So afterwards, the drying phase comes in, where the fan will start to spin to dry the syringes and plungers, and humidity sensor will then come in to detect the level of humidity. So we detect the level of we detect whether the syringe are dry or not using our humidity sensor. So if humidity level is more than 70 gram per meter cube or 75 gram per meter cube, it will be deemed as clean. So this is where the sterilization will comes in for about 10 minutes. So afterwards, 2 steps will be done concurrently, which is starting of camera for syringe and plunger detection, and start the stepper motor to oscillate the rack. So a decision will then come in to ask if the syringe and plunger is clean. So if it is clean, the nurses will then be notified using SMS or mobile application to show that the syringes and plungers are available for use, and the process will end. However, if it is not clean, right, the ml count will then be incremented by 1. So let's say this ml count is more than 1, which is example 2, 3, 4. It will then proceed to the washing phase. However, if it only fails once, which is the ml count is 1, it will then go to the rinsing phase. Yeah. So now I'll be passing over my time to Joseph to go through the block diagram.
Okay, thanks, Natasha. So next, I'll be talking about the block diagram. As mentioned before by Natasha, she mentioned about the process flow. So from there, we actually came up with the components that will be used throughout this process. So as mentioned as well, we also identified the 3 different processes, which is washing, rinsing, drying phase, and sterilization phase. So for the washing phase, basically the components that will be used, most importantly is the syringe, then followed by the ultrasonic cleaner to remove the contaminants, followed by the rinsing and drying phase, whereby the pump will be used to pump the water out. And then after that, the rinser and the stepper motor will turn on for the rinsing phase, and then the fans will be used for the drying phase. Next, it will be the UV light that will be used for the sterilization phase, and using Arduino and Raspberry Pi to communicate, we'll be making use of the camera module and the temperature and humidity sensor module to set the conditions. And when the conditions are already met, whereby the syringe is detected as dry or clean and clean, then after that, it will let the user know through SMS notification or LCD display. Next, I'll let Hong Shen talk about the design phase.
Right, thank you, Joseph. So first of all, what you see here is a Q&A chart. Basically, it allows us to turn the customer requirement into technical requirements so that we are able to build our prototype device based on the clients, which is the nurse, on what they want. So for example, like sterilization. So for the next 3 slides, I'll briefly show through our concept ideation that we managed to draw. So this is design A. Next, this is design B. And this is design C. Okay, next. So basically, with these 3 concepts, right, we need to decide that which one of these concepts is the best concept, and that's why we have this concept screening matrix. So basically what it does is that it takes into the pros and cons of each design, and then we assign a score based on whether it's good or bad. So if it's good, we give it a +1 score, and if it's bad, we will give it a negative score. So at the end of this concept screening matrix, the one with the higher score will continue on to the next phase, and the one with the lower score will drop out. All right, next. So in the second concept screening matrix, we take into account of the selecting criteria. So like for example, automation. So this is one of the highest top requests by the nurses, that they want this thing to be fully automated so that they can attend to other things or the syringe are being washed itself. That's why it has the highest rating. And then once again, of course, we give the score to the design A and B, and by calculating a total score, we will then reach the decision of which design we want. However, in this case, both designs have a pretty close score. Therefore, we combine the 2 designs together and come up with a final concept. So in this final concept, as you can see, taking from design A is able to pump in and water out. So this device uses an ultrasonic cleaner to clean the syringes, and that's why we need a tank full of water. Taking from design B are the separate compartments. So there's a dedicated electronic compartment to store all the electronic components such as the Arduino Mega or the Raspberry Pi camera. In addition to that, from design C, they have the UV lights. So we incorporate UV lights into the storage for the syringes so that when the nurses need the syringe at any time, we know that the syringe is already disinfected and it's ready for use at any time. So moving on, I will now show you the CAD model of our final concept. So this is an isometric view of our CAD model. Next, there's a few more angles to get a better perspective. Next, and finally, this is like a breakdown, like a exploded view of the entire product. So you can see like the Arduino Mega or the Raspberry Pi in there, as well as the UV lights and how they are assembled together. So now I'll be handing my time over to Fabrice, who will talk about the product specification and what material we may
Thank you,
choose in the progress.
Thank you, Hong For the design parameters, we have a dimension of 61 by 31 by 33.5 cm. For the material that we're going to use is stainless steel and polycarbonate. For the weight will be 21 kg. For the capacity of syringes, 4 for washing and 8 for storage. So the rest of the parameters that we considered are power, processor, connectivity, sensors, actuators, interface. And then for the washing time will be 20 minutes, rinsing time will be 10 minutes, drying time will be 30 minutes, and the overall price will be $480. Next slide. So this is a overview of the prototype. Next slide. So for a selection of material, the body will be stainless steel based on the properties, which I'm going to show you in the next few slides in the Granta. And for the previous slide, for the transparent roof and the storage door will be polycarbonate. Okay, next slide. So for the body casing, we created a graph based on the tensile strength and the yield strength. As you can see, stainless steel is one of good materials. Next slide. So the next one is the melting point against the price. So as you can see, stainless steel has a low price and also has a good melting point. Next slide. So for the transparent roof and UV light casing, we created a Granta graph based on the transparency and the price. As you can see, the polycarbonate has the best transparency and also is low in price. Next slide. So the cost of manufacturing we're going to use for the fabrication process is plasma laser cut, and for the assembly is spot welding. This is for the body of the product. So the total cost will be $268.20. Next slide. So for the transparent roof and the storage door, it will be manufactured using injection molding. So the total price will be $7.46. So now I'm going to pass over to Joseph to talk about the circuitry wirings.
Okay, thanks for those. Now I'll be covering the circuitry wiring. Next. So now, basically what was covered from the block diagram and the product specifications, we have already identified what are components that we'll be using in the wash, rinse, and dry and sterilize phase. One thing to take note of though is that we'll be using LED strips instead of UV light because of the limitations that we have. And then after that, another thing to take note of is that we'll be making use of MKR Wi-Fi 1010 to enable like Wi-Fi module in the Arduino Mega. Okay, next. So basically, instead of like clumping all the components together in the circuit, I decided to actually show based on the different components, then based on which is the best relation one, and then after later, from there we will just explain. So in this case, we'll be using the LCD display and the temperature and humidity sensor. So what is basically going on is that the temperature and humidity sensor will be showing the levels in the LCD display, and the potentiometer will be basically used to show to change the contrast of the LCD display to show for better display. Next. Next, we'll be talking about a 5-volt fan. So basically, we'll be using 2 fans, but just for the proof of concept, we'll just be showing one. Basically, we'll be using one transistor, 2N222, in order to control the 5-volt fan using the electrical output. Next. So next, I'll be talking about the ultrasonic cleaner and the rinser. Both will be used, replaced with LEDs in order to show the proof of concept. As ultrasonic cleaner and rinser, we are advised not to cut the wires and as well as not to purchase. They are connected to the pins in order to just control on and off. Next. Next, we'll be talking about the liquid pump and the UV light. For this case, it's slightly different as we'll be making use of 12 voltage. So what we did is we used 12 volt adapter in order to connect to the circuit, and as well as a module relay to give the liquid pump and the LED strip the ability to control using Arduino Mega. Next. So for this case, we'll be using a stepper motor. One thing to take note of is that we will not be using Arduino Mega directly to power the stepper motor. This is because it's not advised through research. If not, you will overfry the board because the stepper motor is constantly draining the energy from the circuit. So therefore, we'll be making use of the battery pack and a buck boost converter in order to power the stepper motor. Next. And last and not least, we'll be covering the Arduino Mega and MKR Wi-Fi 1010. So basically what they are doing is that they'll be using serial communication to communicate one another to enable Wi-Fi. This is the most important aspect because this is to ensure that it allows the user to be able to access through mobile application and control the entire design. Next. Next. Yeah. So next, I'll hand over to Junying to talk about the machine learning.
Joseph. So why do we use machine learning? So in order to detect dry or wet syringes, we have the humidity sensor, which will serve as the best gauge to detect. However, to detect clean or unclean syringes, there are no sensors that could directly detect residues. Hence, the team has decided to try out machine learning to differentiate between the clean and unclean syringes. Next. So there are 2 ways that we could detect, which are image classification and object detection. So we decided to employ the use of image classification as the design of our machine requires to detect one object at a time, and image classification is sufficient to do so. Next. Next. So here's the system diagram of the entire process. The PyCam together with the detection algorithm in the RPy will detect if the syringe is clean or unclean. So if it's clean, the process will be redirected back to the washing stage. If it's clean, users will be notified through the SMS module. Next. So we decided to use the mobile net V2 and will justify why more in the report. So the accuracy of the train model is relatively high, but from this image we derive after training the model, it's clear that the validation loss is high as well, and also increases after every training approach. This is an issue of overfitting, which we will also explain more in the report. Next. So next is the mobile application. So why do we implement the use of mobile app? Next. So firstly, nurses will have the ability to control the machine anywhere and anytime, as well as to view live status, which will increase the efficiency of the nurses. Next. So here's the cost breakdown to implement a mobile app for a year, which costs around 3,000. Next. So here's the system diagram. The communication used for the application is through the REST API. So when users start the machine, data will be sent to ThinkSpeak, which will then be received by the Arduino to activate the machine. So similarly, in order to show the live status of the mobile application, data will be sent from the Arduino or Raspberry Pi to ThinkSpeak, and the Flutter application will receive the data via the REST API. Next. So even though both implementations are feasible, we have a few justifications as to whether we should employ the use of ML as well as the mobile app. So even though there are no sensors that can directly detect if there are residues lurking in the syringes other than leveraging the use of the computer vision, it is still an overkill to implement machine learning, as it is extremely expensive for a small-scale product and completely unnecessary if the prior processes are done properly. So on the other hand, the downside of implementing a mobile application is the cost of implementing. However, since it's a simple mobile application which does not require additional costs for content management system database or heavy maintenance of the application, the benefits outweigh the cost of deploying the mobile application. Next. So I'm going to pass on to Natasha to explain more on the project justification.
Okay, so for the project justification portion, there are two parts. The first one will be the ultrasonic cleaner. So one of our team's hypotheses is to ensure that the ultrasonic cleaner will actually be able to get rid of almost all stains or residue in the syringe and plunger in 15 minutes, which actually tallies with our process flow. So as you can see from this GIF itself, it actually tallies lah. Yeah. So the next one will be in terms of machine learning. So as you can tell, milk is harder to detect as it's almost the same color as the syringe and plunger. So as you can see from the picture itself, it is actually able to detect as well. So now we will be showing the demo video.
The mobile application feature allows users to keep track of the status in real time. This is so that users will know roughly how long more it will take and make necessary plans. This mobile application shows all the different stages at which the machine is at. After the whole process takes place, it will redirect to the home page, where users can choose to start the process again for a new batch of syringes and plungers.
Okay, so with that, we have actually come to the end of our presentation. So thank you for your attention.